Dear students, welcome back to the medium question discussion of SLMC 13. Let me share the screen. Yeah, so we can start from question number 11. Yeah. Now question number 11 is a geometry question. It's about a triangle and has an area of 18. So what do we need to find? Area of the triangle ABE and the area of the quadrilateral BEFT are equal. Okay, area of the triangle ABE. So we need to find the area of the triangle ABE. So when it comes to the areas, what we should look at is the ratio of the area. Is the ratio of the uh, linear segments uh, of a line, like the ratio between the length of the line segments. Like for example, if this is there, so this is one of the main theorems in geometry. So if the ratio is 1 to 2, the area is also has the same ratio. So this is one of the principles used in this question. Yeah, so let's come back to the question. So we need to find the area of ABE. So in order to find the area, and we also know the area of the triangle ABC, and if that is ABE, what do we need to find? So one way is to find this ratio. If we find this ratio, the ratio between CE and EB, we can easily find the area of ABE. Can be easily found. So how do we find it? CE EB ratio equals to AB, so ACE area and since we know the area of the whole triangle, we can just find ABE area equals to ABC area into PE divided by PE done PE plus CE. So when we know this ratio, we can find this. Okay, now this is how we approach. Now let's see how we can find this ratio. So in order to find this ratio, we should find one way is to find whether whether there's a parallel line. So let's do this construction, and we are yet to use the information given. So what is the information? The quadrilateral lateral BEFD and ABE areas are equal. BEFD and ABE are equal. So we can see there's a common area. Let's say call this O. So BEOD is common. When we remove the common part, we can see that OFE area. OFE area equals to ODA area. And we can also see that when we add the same, I can see that AFE triangle area equals to AFD triangle area. Now what can we conclude? Now what we did was we just used information given. With this information given, we saw that EFO and DOA are equal, and when we add the same triangle again, we found that we have a uh, common base, and with a common base, you have two triangles which have equal areas. So what does that mean? That means ED and AC are parallel. When ED and AC are parallel, the ratio between BE and EC can be found. Since they are parallel, BE, so BEEC ratio equals to 4 divided by 5. Because the reason, when a parallel line uh, intersects with another side of a triangle, the two sides are uh, bisect. Two sides have the equal proportion. So by using this, now we had to find this BE and BE plus CE ratio, and now we know that it's 4/9, and ABC triangle area is 18. So the answer is 8. Answer is 8. Hope this is clear. Now the next question. Right. So we have new question. We need to find this value. And can you see that all the answers are independent of x and y? What does that mean? That means y over 1 minus x can be found. So we should use these equations to find y over 1 minus x. Now let's do some changes, because we have these in terms of 24. So let's write this 48 in terms of 24. Now we can see that, let's do some simplification. 24 to the power x equals 1 minus x. Okay, there's some positive result because you can see 1 minus x here. We have 1 minus x here. Right? We have 1 minus x, the final answer. And you have 1 minus x here. That means we can use it. And again, we just need to find this part only. So that means 24 to the power 1 over 3 divided by 24 to the power 1 over 3. Okay, so this is what we need to find. Shall we try to find 24 to the power y over 1 minus x? So you can see 24 to the power x over 1 minus x equals 2. And when we take the root of 1 minus x, this becomes 1 minus x to the denominator, and the power of 2 disappears. But what we need is 24 to the power y. So we take the root from both sides, root by x. And we need y to the numerator. So this is a good result. So now we have 24 to the power 24 to the power y over 1 minus x equal to 2 to the power y over x. But still it's not independent of y and x. But if we find this value by using the two equations, we may be able to find some independent value. And you can see that x and y have the same degree and same order. Why don't we try to divide one equation from the other? Means we have 48 to the power x equals 2, 48 to the power y equals 3. Let's take the logarithm. X log 48 equals log 2. Y log 48 is log 3. So y divided by x is log 3 to the base 2. In other words, 2 to the power y over x equals to 3. Now we can substitute. In the final answer, 24 to the power 1 over 3, 24 to the power 1 over 3, so 24 to the power y over 1 minus x to the power 1 over 3 plus 24 to the power 1 over 3. 24 to the power y over 1 minus x is 2 to the power y over x, that is 3. Is 3. This equals 24 divided by 3. Cube root of 8 equals 2. Answer is 2. You can see how we approached. So we observed that the answer is independent of x and y, and we were trying to find the y over 1 minus x, and we used the given equations. Since the 24 is there, we simplified or rearranged the equations to include 24 there, and then we were rearranging the terms to come up with 1 minus x part, and then we somehow created 24 to the power y over 1 minus x, and then we came up with 2 to the power y over x, and we wanted to make it a constant, then we use this 2 again, because the first result just follows from the first equation. As you can see, it just follows from the first equation, and then we use both at once, and then we got the second result. Finally, the answer. Okay, hope this is clear. Okay, now there's another interesting logic question. This kind of logic question we always have in SLMC. It's about the land of liars, so it's about like people. Some people are telling truth, some people are lying, some people are like alternatively telling truth. So we use this information to arrive at a result. Now let's read the question. So the land of liars. So there are two clans, red and blue. Red always lie, always lie. Blue always true. And 2021, people are standing in the shopping queue, and first person claims that everyone behind him is red. Okay, people, and this person claims everyone behind him red, and everyone else claims person in front of front red. He claims everyone red. Now what is asked? How many blues are there in the queue? In general, when we make statements, it may be possible that we can't arrive at some conclusions. But when you ask this question, we make sure that this conclusion can be achieved. So in this case, how many blues are there in the queue? That means by using these statements completely, you can conclude completely and consistently. You can conclude how many blues are there in this queue. Right. So this is just easy approach. So let's start from the first person or the person in front. So he claims that everyone behind him is red. So now let's start with an assumption. So here what we are doing is just starting with assumptions and checking whether they are consistent. Like if the assumption contradicts itself later, then that means the assumption is false. So we start with assumption and we use that assumption until we arrive at a contradiction. So if we arrive at a contradiction, that means the assumption is false. So let's assume that the first person or the person in front is blue. It's blue. So if he is blue, then he says everyone behind are red. So this is something true. This is something true. But the problem is red person. So now assume front person is blue. So that means he says truth. That means all behind are red. That means all behind say false. So what do they say? All behind say false. So, but the problem is a person in the middle of the queue, all behind the is false. That means middle person says false. So that means there is at least one person uh, behind who is blue. Can you see that? All behind say false, and middle person is also in behind. He also says false, and what he says is uh, front man. I mean, his front person red. It appears to be false. That means it becomes again blue. Can you see? So we started with all behind are red, and we arrived at there's at least one person who is blue because red people lie. So we started with all behind are red, but red people lie. So at least one of them are blue. So these are inconsistent. So that means the first assumption is false. That means front person blue is false. That means front person must be red. Right. Now let's do it backwards. If the front person is red and the person behind is saying that he is red, I mean the first person, right? 1, 2, 3, 4. First person is now red. Now we have concluded it. Now second person is saying that also. Second person says that one is red. That means second person is saying true. Hence second person is blue. Third person. So you can see inductively you can determine all the colors, because for each person the color of his uh, person in front of him can be determined. That means all the colors can be determined. So third person sees blue, but he says he's red. That means he's saying false. So you can see this goes on and on. So the question is, how many blues are there in the queue? So there are how many? 20, 21. So we start with red. One is red, and 2021. 2021 is also red because all the odd ones are red. As we ask for the number of blues, so even ones are blue. So since 2021 is an odd number, uh, so there should be more reds than blue. So it's like how many even numbers are between 1 to 2021. So the answer is 1010. So there are 1010 blues, and there is one more red, 1011 reds. Okay, answer is 1010. Okay, now question 40. Here there's a equation. What are the ABs where ABC are real numbers? None of the denominators is equal to 0. That means B plus C, A plus C, A plus B are not non-zero. How many possible real values are there for K? Okay, this is easy question. So that means we need to construct an equation and solve it for K. And just find out how many values are there for K. So how can we do it? Can we do it? Since B plus C, A plus C, A plus B are non-zero, we can see there is some connection between the denominators and numerators. If we sum up the numerator and denominator, we can see a common factor. And if it is possible to take the denominators to one side, numerator to one side, we can have a plus b plus c as a factor, and we can also have k as a factor. So you can see that these are symmetric. So when we sum them up, we can have a factor. So since we have a factor, we can easily find the roots of this particular equation that we are going to derive. So let's do it. K into b plus c plus a plus c plus b equals a plus b plus c. Just say a plus b plus c into 2k minus 1 equals 0. Right. Now k equals half. So k have one value. But let's see whether there are other values, because whenever a plus b plus c equals 0, also we have a solution. Now let's say when a plus b plus c equals 0, b plus c equals minus a, and a plus c equals minus b, a plus b equals minus c. This makes k equals a over minus a equals b over minus b plus c over minus c. And we can actually find ABC values. This condition can just find some positive and negative numbers, so that a, b, c are non-zero, so that a value for k exists. Because otherwise, if one of them can be 0, this does not happen. But we can find ABC values such that this happens. So when we find ABC carefully, then there's another k value which is 1. Means we have two values for k, which satisfy this equation, and no more. So the answer is 2. So one value we directly derived from the equation, and then we use the other factor of the equation, and find another k value corresponding to it. Okay, that's done. Now question 15. Which statement is always correct if p is a prime number? Okay, so we start from A. Some of them just have count examples. So p minus 1. So we can start from very small number. So if p equals 3, p minus 1 is 2, which is a prime number. So that means this is wrong. P square minus 1 is not a prime number. Okay. Again the same argument, equals to or just we can see p minus 1, p plus 1. If p minus 1 is 1, that means we have only one factor. That means it can be prime. So if p is prime and p plus 1 is also prime, that means p squared minus 1 is prime. So if p is 2, p plus 1 is 3. This implies p squared minus 1 equals 2, which is prime. In other words, we can just start p equals 2, p squared minus 1 equals 2 squared minus 1 equals 3, which is prime. So this is also not true in general. Because what we ask is which statement is always correct. Right. Now let's see C. 2 to the power 2p. Okay. Here also, just assume for C, p is 2 because 2 is a prime. 2 to the power 2 to 2 minus 1. This we can see 2 to the power 2 into 2 minus 1 plus 2 to the power 2 square. 4 minus 1, 4 plus 1 is not prime. It's 15. It's not prime. So saying that this is always a prime number is incorrect. Right. Now D. D squared plus p plus 7 is a prime number. Okay. Now what we can do is um, every time if we are going to find a count example, we are finding some factorization. So that is one common method. So if we can find a factorization for these, some factorization plus some common factor, then it would be fine, because we are going to find a count example. Let's say p plus p plus plus minus 2 plus 2 plus 7. This makes square plus p minus 2 plus 9. This is not the only way. Like I'm just finding different methods. So you can have your own method, because this is just coming up with a count example. So you can address. You can see whenever it is sufficient to find p plus 2 as a uh, factor of 3. Luckily, like we have when p equals 7, p plus 2 is 9. That means this whole thing is divisible by 9 when p equals 7. That means this is also false. So the only possible answer is E. So when you are doing the exam, you don't have to verify whether E is correct, because the time is critical. You don't have to verify, but I'll verify. So the divisibility, when we say the divisibility, we just need to check for the modulo. Like we start with each modulo class of 8 which are applicable for primes, because not all the modulo classes of 8 are applicable for primes, but we take only the ones that are applicable and then use those uh, modular classes to compute the modular class of the resulting expression, and then prove that that modular class is 0 mod 8. Okay, now let's see what are the possible modular classes mod 8 for any prime. So 1 mod 8, 1 mod 8, can it be a prime? Yeah, let's say 1 mod 8 can be a prime, and 2 mod 8 can be a prime when p equals 2, when p equals 2, but after that 2 mod 8 is not a prime. So let's check whether when p equals 2, what happens. 2 square plus 7 minus 2, here 2 minus 2 is 0, so 0 is divisible by 8. So when for p greater than 2, 2 mod 8 is not prime, so we are not considering it, because for p equals 2 we have proven that it's divisible by 8, so we need to prove for all primes. So after p equals 2, we don't consider 2 mod 8 as a prime, because we are going to prove for just p greater than 2, and 3 mod 8 can be prime. 4 mod 8 cannot. 4 mod 8 cannot. This is 4k plus 8. 4 is the common factor. 5 mod 8 can. 6 mod 8 cannot, because 6 and 8 have 2 as a common factor. So any 6, 8k plus 6 is not a prime. And you have 7 mod 8. So we only have 1, 3, 5, 7 mod 8. And I can tell you a different method, because we know that after p equals 2, no prime is an even number, so you don't have to check all these modulars, you can just omit the even modulars. So 2, 2, 4, 6 and 0 mod 8 can be removed directly without even considering, because after p equals 2 there's no even prime, so that is efficient. Now let's see, whenever p equals 1, 3, 5, 7 mod 8, what happens to this expression, p squared plus 7 into p minus 2. So for 1 mod 8, it's 1 plus 7 into minus 1 mod 8. So you can see that always p squared plus 7 is 0 mod 8. That means the total expression is 0 mod 8. So this is 1 is for 1 mod 8. So let's do for 3 mod 8. Uh, 16 mod 8. So 16 is 0 mod 8 divisible by 8. For 5, 5 square plus 7, 32. 0 mod 8. Finally 7. I'm just trying to prove that, but you don't have to prove it when you find out the correct answer. So always when you do these MCQs, use the elimination method and just eliminate impossible answers, so it will be very easy. Okay, now finally 7 more 8. Okay, so I think in this case, other than finding a result for all all p's, uh, if you see that you can find a count example, always start with a count example, so it will save time. Problem 16. A real value function satisfies f t plus x equals f3 minus x. So this means the function is symmetric around y equals 3. So first you have to figure it out. It is symmetric around y equals 3, so it becomes something like that. Right. So what is asked? Fx equals 0 has 6 distinct roots, 6 different roots. So fx equals 0 are the function where it touches the x-axis. So since this is symmetric, if there is a root in the left side of the y equals 3, there should be a corresponding root in the right side to the y equals 3 as well. So that means, so you can see that there are 6 distinct roots. That means you have 3 roots at left, 3 roots at right. And since this is symmetric, each root can be written in the form of either 3 minus, let's say, the first pair of roots, 3 minus x1, 3 plus x1. So let's say this is x1, this is 3 minus x1, this is 3 plus x1. Let's say there's another root, 3 minus x2, 3 plus x2, because they are symmetric around 3. Finally, you can have 3 minus x3, 3 plus x3. Now the question is the sum of the roots. Sum of the roots. So sum of the roots can be easily calculated. You can see that x1s are cancelled out, plus and minus x1s are cancelled out. So when we sum these, cancelled out, cancelled out, cancelled out. 3 into 6, 80. Answer is 80. Let's go quickly for the question 17. Sequence of integers defined as x1 equals a, x2 equals b for some integers. So here the integer is a keyword, and after the second one, it is the product of the two previous terms. So xn equals say minus 1 into say minus 2 for n greater than 2. If there is an integer k such that xn equals k for all integers, how many different values can a b take? Okay. Now first we have to gather the information, we have to process the information that x3 equals k, x4 equals k, x5 equals k, to find, because this is a very strong constraint. By using this strong constraint, we can find values for k. Right? So this is the method. Find values for k. Find possible values for k. And for each of these possible value, we can determine what are the possible AB values. Okay, now let's see. X3 is k, x4 is k. Now we know that x5 equals x3 into x4, which makes x5 is k, x3 is k, x4 is k. This makes k square equal to k, which makes k equals 0 or k equals 1. So k can take two values. In this case, it can be 0 or it can be 1. So now let's see the two scenarios. Let's say when k equals 0 and k equals 0. Now you know that a greater than or equal to 0 is given, b is between 0 and 5. When k, no, let's start with k equals 1, it's easy. When k equals 1, you know that x3 equals ab, means ab equals 1. When k equals 1, x3 equals 1, x3 equals ab, ab equals 1. Since a and b are integers, both are positive, it must be the case that a equals b equals 1. So 1 comma 1 is one possible answer. Now let's check the other answer. Let's say k equals 0, x3 equals 0. Why are we using x3? Because that is the direct use of a and b. After that, a and b are not used. So we must start from x3 to find the values for ab. So x3 is 0, ab is 0. And we know that b cannot be 0. B is in this positive range. And only a can be 0. And b can be anything within this range. 1, 2, 3, 4. So there are 4 possible values: 0, 1, 0, 2, 0, 3, 0, 4. So we have one value from here, 4 values from here. That means we have altogether 5 values. The answer is 5. Okay. So let us look at question 18. Okay. f is a real valued function defined on real numbers such that fx plus y equals fx plus fy for all real numbers or real numbers. So that is something as a keyword. And you can see that when there is a summation, you can reduce, when there's a summation inside the function, you can reduce it for two uh, uh, for a summation of two functions. Um, and we are also given that f of root 2 is 1. So let's have a look at what is needed to be computed. Now we know that we have only f root 2, and we can do a reduction to addition operation an addition operation, but only from the blocks of root 2. So it must be a sum of root 2's. So this must be written as a sum of f root 2's. Otherwise we can't find this. So that means it should be root 2 into some natural number. So this is the first thing we have to figure out. So this value, that means f root 2 into some natural number, and this natural number can be should be computed. That means this summation should be written in the form of this. Now let's see how we can do it, because you can see, so 2 to the power half is root 2, 2 to the power 2 over 3 is root 2 to the power 3 plus root 2 to the power 5 plus root 2 to the power 21. You can see that this is geometric progression of uh, common ratio root 2 to the power 2. Okay, so first we can take root out, because that is the first part, and then 1 plus root 2 to the power 2 plus root 2 to the power 4 and so on, root 2 to the power 20. F root 2 into, okay, sum of geometric progression, uh, first term into common ratio is 2, r number of terms, how many number of terms? It's just the odd numbers, right? Odd numbers between 1 to 20, 21. That means 1 or 11. 1 or 11. Minus 1 divided by 2 minus 1 is equals, what can we see? This n is found. So this is n. So this is the answer. So we know that if root 2 is 1, so that means something like root 2 plus root 2 root 2 4 10 to the power, so if, 2 to the power 1 or 11 minus 1 times. Means we know that if root 2 equals 1 into 10 to the 2 to the power 1 or 11, this one, this is the answer. Yeah. Hope this is clear. On the next question, there are 10 stairs in a staircase. You can climb one or two stairs at once. In how many different ways you can reach the top? Okay, so there are several ways to do it, but if you are going to use brute force to count this would take a long time. Instead, you need to find a method. So let's say this is the 10th step. So we have to find a recursive formula for this. So that means, since you know that it's just one or two stairs, to come up to the 10th stair, you can come from 9th stair, or you can come from 8th one. So if we name F10 to be the number of ways that you can reach the top, it can be from the 9th stair, or it can be from the 8th stair, and the number of you have the number of ways to reach 9, and you have the number of ways to reach 8. So these two are orthogonal, or these two are independent, because the number of ways to reach 8, and then like it's like reach 8 and then 10. So this is one event. Reach 9 and then 10. So it's another event. So there is a number of possibilities. There's a number of possibilities. These two should be added to compute F10. And you can see that this recursion can be computed for other ones as well. When you consider 9th step also, you can have the same thing. If you have heard about the Fibonacci sequence, we are getting the same sequence. So now if you know the Fibonacci, so this is very easy. But now if you have not heard of it, I will derive it. Now again, still we have just a set of function values, but we should know the base value to do the calculation. That means we should know the F2, how many steps to reach, how many ways to reach the second step, F1 plus F0. 0 is the ground level, and to reach the first step, there's only one step. So that is the base. That's the base case. And F0 to reach the ground also, that's just one way. And now we can do it from the base, from the bottom. You can see F2 equals 1 plus 1 equals 2. F3 equals 2 plus 1 equals 3. You can see F4 equals F2 equals F3, 2 plus 3, 5. You can do it until you arrive at the final answer. F5 equals F3 plus F4, 3 plus 5, 8. F6 equals 8 plus 5, 13. F7 equals 13 plus 8, 21. F8 equals 21 plus 13, 34. F9 equals 8 plus 7, 55. F10 equals 55 plus 34, 89. This is the answer. Final answer. Hope this is clear. Now let's move on to the last question in the medium section. In the pyramid given below, a cell takes the value 1 if two cells that is sitting on have the same number, and 0 if they have different values. So let's see the example given. So value 1, if for example this becomes value 1 because 1 and 1 are same, and this becomes 1 because 0 0 are same, and this is calculated from the bottom. So you start from the bottom, and by considering the bottom values, you go up. So here we can see 1 0 different values, so hence 0 0 1 different values. Okay, let's see. Similar values 1 different values 0. Okay, and now the question is, how many ways can the 4 bottom cells can be filled so as to produce 1 at the top of the pyramid? Okay, now it's like we start from the beginning. So when we if we need 1 at the top, there are two possible configurations: 1 1 or 0 1. If you notice that for each starting number there is only one configuration, this is the key. If you start with 1, there is only one consideration, only one configuration. And if you start with 0, there is only one configuration. That is possible. And for each considered configurations, in the next level also, if this is 1, you can, if you start with 0, the next value is totally determined. There's no choice. If you start with 0, for the top one to be 1, this must be 0, and this must be 0. Must be 0. And if you observe that, that means you start from the top. So top should be 1. For top should be 1, the next layer can start with either 1 or 0. Whenever it starts with 1, all the rest of the values in the cells can be determined. Same goes with start with 0. So that means at each layer we have two possible configurations. So one configuration to start with 1, one configuration to start with 0. Each layer, because each layer we have the choice to start with 1 or start with 0. Whenever we start with 1, in order to make the cell above 1, we have only one choice. And since we have three layers to try, so we start 1. So we have two choices: start with 1 or 0. And whenever you try the two choices, depending on that choice, for each choice we have to find two choices. For the next layer, find two choices. The next layer. So altogether, 2 into 2 into 2, 8 choices. You can see this is generalizable, not only for four layers, but for any number of layers. It's 2 to the power uh, number of layers minus 1 should be the number of possible configurations. So this is 8. Thank you very much for listening for the medium section. So let's meet with hard section.